All right, so for example 2, we have f of x equals x squared plus 2x. Okay, so just like before, we are going to find our key pieces of information. So the y-intercept is 0, c. So in this case, our y-intercept is 0, 0. Because there is no c value, my a value is 1. My h value comes from negative b, so negative 2, divided by 2a. So that would be negative 2 divided by 2, which is negative 1. And then to find k, we're going to take that negative 1 and plug it back in. So for k, you get negative 1 times negative 1 plus 2 times negative 1. So you get positive 1 minus 2, which is negative 1. So we have a, h, and k.
You're able to scroll down for me.
So my axis of symmetry comes from x equals h, so negative 1. My vertex is h, k, so negative 1, negative 1. And then we're going to start our table. So again, it's 0 plus h, so it would be 0 plus negative 1, which is negative 1. And then it is 1 plus negative 1, so 0. And then 2 plus negative 1, so 1. And then 3 plus negative 1. And then 4 plus negative 1. And then our y values come from ya plus k. So in this case, it would be 0 times 1 minus 1, or negative 1. And then it's 1 times 1 minus 1, so 0. And then it goes 0, 1, 4 times 1 minus 1, so 3. And then 9 times 1 minus 1, or 8. So we plot those coordinate points, and we have negative 1, 0, 0. So that's up 1, right 1. So we also go up 1, left 1. And then we have 1, 3. So that's 4 up and 2 to the right. So we go 4 up and 2 to the left for my axis of symmetry. And then we go to 2, 8. So that's 3 to the right, so we go 3 to the left. Connecting our points, we see that we have 2 roots at negative 2 and 0. So again, I have 2 roots, or 2 solutions, at negative 2 and x equals 0. Alright, so we have previously talked about the fact that if you are going to solve a quadratic, it has to be set equal to 0. So what we're going to do is move the x squared and the 8x to the opposite side. So I have 0 equals x squared minus 8x plus 16. So my a value is 1. My h value is negative b divided by. So our h value becomes 4. And then to get the k value, you have to plug 4 in. So 4 squared is 16. 4 times 8 is 32 plus 16. So 16 plus 16 is 32. And then minus 32, we get a k value of 0. My axis of symmetry then becomes x equals 4. My vertex becomes 4, 0. And my y-intercept occurs when x is 0. So when x is 0, y will be 16. So that means my table is going to start at 4, 0. And then we're going to find our remaining points by doing our x plus h, ya plus k. So in this case, my plus h is 4. So 0 plus 4 is 4. 1 plus 4 is 5. 2 plus 4 is 6. So on and so forth. So again, what's nice about the x plus h is once you find your vertex, it usually just increases by 1. The ya plus k is a little bit more challenging. So it's y, in this case a is 1, but what's nice is this time k is 0. So 0 times 1 is 0. 1 times 1 is 1. 4 times 1 is 4. 9 times 1 is 9. And it goes 0, 1, 4, 9, 16 because it's our perfect squares. So 16 times 1 is 16. Plotting these points, we have 4, 0, 5, 1, 6, 4, 7, 9, and obviously 8 16's way off the page, going up and over with respect to the vertex being symmetric. We go to 3, 1, you have 2, 4, and we have 1, 9. So what you'll notice about this graph, as wobbly as I made it, is that it only hits the x-axis once. So since my vertex is on the x-axis, my root occurs at the h value, which in this case is 4. So I have one root or one solution at x equals 4. So just to summarize, when solving a quadratic, you can have 3 cases. One is no solution, and that occurs when the graph does not cross the x-axis. You could have one solution, and that occurs when the vertex is on the x-axis. And then the third case is 2 solutions, and that occurs when the graph crosses the x-axis twice. You can never have more than 2 solutions. All right, good luck on the remaining problems.